Hello, I'm Joe Chadderdon, and I am here today to tell you about the end of an era in the city of Parchment. In 1909, Jake Kindleberger came to the city of Parchment, to a location of the city of Parchment, to establish a paper mill to make parchmentized paper. This area grew and developed around this company, which was originally the Kalamazoo Vegetable Parchment Company, the KVP Company, the KVP Sutherland, Brown Company, James River, and now Crown Vantage. Last fall, it was announced that Crown Vantage had sold the parchmentizing operation to Cybelle Dahl of France, who had bought the business but will not manufacture paper in this area. The parchmentizing equipment and the building will be removed, and there will be no more parchment made in this area.
This is a picture of Jacob Kindleberger. When Kindleberger came from West Carrollton, Ohio, to the area that is now the city of Parchment, it was farmland. Near the Kalamazoo River were foundations of an abandoned sugar beet factory. Here Kindleberger built his parchmentizing plant. The mill grew to 6 parchment machines. Also, there are 6 paper machines, printing, waxing, and other paper converting. After April 1996, the parchmentizing machines will be gone. This video is to be a record for the Parchment Community Library on the making of Waterleaf and parchment paper. The low buildings you see were built between 1909 and 1915. They include the original building of 1909. 20 years ago, the United States had parchmentizing plants in Pennsylvania, Ohio, and Michigan, with a total of 12 parchment machines. Now there will be only one plant with 2 parchment machines in West Carrollton, Ohio. Parchmentizing has always been considered a confidential process. Little is published in the general literature about parchment. These will be the only pictures of parchment machines in the Parchment Library or anywhere else I know of. To make parchment paper, a special paper called Waterleaf is treated with sulfuric acid, neutralized and washed. Originally, the Waterleaf was purchased from Kalamazoo area mills. In 1918, mill number 1 was built with 2 paper machines called the Pusey and the Horn. Waterleaf is made from cellulose fibers. Until around 1930, the source of fibers was old cotton rags. Since then, pulp from wood has been used. Here you have seen wood pulp from rail cars being taken to storage. When rags were used, they were sorted, cut up, and cooked for 12 hours in a lime solution. Then they were bleached, beaten, and made into Waterleaf paper. The two rag cookers are still in mill number 1 and are used to store wax and mineral oil that are used to treat special papers on the Pusey. This one is used to store wax, and this one is used to store mineral oil. To start the making of Waterleaf paper, pulp is brought to the hydropulper room. Here the pulp is being loaded onto the conveyor for the horn paper machine. The hydropulper is a large tank with a powerful mixer in the bottom. Water and pulp are added to the hydropulper and mixed to make a slurry of about 4% pulp that can be pumped to the paper machine. In addition to Waterleaf, other grades of paper have always been made here. On this day, the horn was making blue paper for hospital gowns, and the Pusey was making white Waterleaf. Rolls of paper that did not meet the specifications are cut up and recycled. Water used at the pulper is excess water from the paper machine that is reused. Before the operator can add the blue dye, he must check the water to make sure the acidity is right so the dye will bond properly to the paper. He takes a sample of the water and tests it on a pH meter. Now he adds the blue dye. The conveyor now delivers the pulp to the hydropulper. The blue color in the pulper shows the bales of white pulp that are being broken up in the pulper. In a few minutes, bales of pulp are broken into individual fibers. From the pulper, the fibers are pumped to refiners, where they are braided between metal discs to soften them so they can be more readily formed into a sheet of paper. These are the refiners. This is the control panel and computer terminal that control the wet end of the paper machines. This is a view behind the wet end of the Pusey. The control panel is on the left and the Pusey head box on the right. The gray metal box in the upper center is the Pusey regulating box. The 4% slurry of pulp from the refiners is pumped to the Pusey regulating box, metered to the fan pump, and where it is diluted to 99.5% water and pumped to the Pusey head box. This is the pulp in the Pusey regulating box. A quick look at the machine room with the horn on the right and the Pusey on the left. From the level of the Pusey regulating box, we are now looking down on the paper machines. The blue is paper running on the horn. The white is Waterleaf being made on the Pusey. This is another look at the Pusey regulating box. This is a view of the paper machine room from the horn regulating box level. This blue paper being made on the horn will eventually be formed into hospital gowns. Now we will go to the Pusey and see the 99.5% water slurry extruded from the green head box onto the forming fabric. The fabric is a fine mesh screen. Water goes through the screen and a sheet of paper is formed on the screen. Paper is transferred to the felt, run through presses, and then on to the dryers. These are the dryers of the Pusey paper machine. We are now at the dry end of the horn paper machine. The paper leaves the dryers, goes through smoothing rolls called a calendar, and is wound up into a roll. Before the paper is rolled up, it passes under a sensor for the computers that control the paper machine. Here, beta rays measure the weight, and infrared rays measure the moisture of the paper. These measurements are used to control the pulp to the head box and the steam in the dryers. Before a roll can be shipped, a sample must be tested and approved by the paper tester. We are now in the paper test station. Many tests can be run here. These include bursting strength, carrying strength, tensile, porosity, smoothness, moisture, caliper, stiffness, color, brightness, opacity, absorbency, and weight per ream. Here the tester checks the color of the blue paper. Now he passes the blue paper over a light box to look for defects. This porosity test determines how much air will pass through a sheet under standard pressure in a given time. When tests are complete, results are entered into the computer and sent to computer terminals at the paper machine so the machine crew can make any necessary corrections. We now return to the Pusey paper machine to see a roll of Waterleaf rewound so it can be sent to the parchment machine. As made on the paper machine, the paper is too wide for the parchment machine. The Waterleaf is cut into 2 rolls and transferred to the parchment department. At the parchment machines, the water leaf is immersed in sulfuric acid for about 2 seconds. The acid starts to dissolve the cellulose fibers. Before the structure of the sheet is destroyed, the paper is immersed in a water bath and the dissolved cellulose is precipitated to form a film on the sheet. This film gives the parchmentized sheet wet strength and grease resistance. This is the parchment machine room building facing on Riverview Drive. This is an overview of the parchment machine room looking down on number 23 parchment machine. We are now at number 55 parchment machine. You see a roll of water leaf being run into a vat that contains sulfuric acid at 67% acid. It passes under a tube in the acid up to press rolls where the excess surface acid is removed. The washing and neutralizing process starts now. There are 2 sections in this process. In both sections, the water flow is counter to the direction of the paper. The first is called sour water and results in reclaiming over 90% of the acid for reuse. Overflow from the sour water section at about 40% acid goes to evaporators where it is concentrated for reuse. This is still the sour water section. The low black press is the last sour water section, and paper now enters the washing section. Here again, the water flow is counter to the direction of the paper. In the middle of the section, a soda ash solution is added to complete the neutralization of the acid. This is the tank where the soda ash is added. The last part of the wash section is clear fresh water to remove any traces of acid or soda ash. This is the last washer vat. The next vat applies a solution of plasticizer to make the finished sheet more flexible. The paper goes over 2 sections of dryers. The first section dries the sheet so it can be treated at the size press with a solution that gives the paper release from sticky materials. This is the size press. The treatment is sprayed onto the parchment and the excess is removed by press rolls. Now the paper goes over the final dryers. This paper is used to interleave or wrap sticky materials such as rubber during manufacturer shipping. Ordinary paper would bond or stick to the materials. This is the finished roll of parchment. Next we go to number 23 parchment machine where they're making silicone treated parchment that will be used in bakeries. We've seen the acid vat in the sour water section, and the parchment is now going into the wash section. This parchment will be used as pan liners in bakeries, and sweet rolls will be baked on them. The sweet rolls will release readily from the parchment saving the cleaning of the baking pans. Now the parchment goes over the first dryer section. After this dryer section, the parchment is treated with a silicone emulsion at the size press. Here you see the silicone emulsion being sprayed onto the sheet and the excess being removed by the press rolls. The silicone treated parchment now goes over the final dryer rolls and is wound up at the reel. Here at the reel, you'll notice that the roll of silicone parchment is quite large. This means they are near the end of the roll of Waterleaf. Another roll of Waterleaf must be spliced on to continue the parchmentizing. Next we go to observe this splice. The operator has put glue on the leading edge of the large roll of Waterleaf. He now starts the large roll rotating at the speed of the little roll. He brings the large roll against the small roll and the lead strip sticks to the paper from the small roll. The large roll is now going through the parchment machine and he breaks off the little roll. The new roll is now being carried through the parchment machine by the last of the old roll. The new roll has now reached the reel. The operator is about to use a blast of air to transfer the parchment to the new reel. When they need to start a roll of Waterleaf and no paper is running in the parchment machine, the crew must thread the paper through the parchment machine by hand. We will watch this process on number 41 parchment machine. You will see the man tear a tail or a narrow strip of parchment that will be thread through the parchment machine. Before he threads the tail over these rolls, he checks them to make sure that they're all clean. They have to be dry and free of all dirt. There are two operators on a parchment machine. The one on the wet end is called the washerman, and the lead man on the dry end is called a dryerman. The washerman will thread the machine. The dryerman and another washerman will help. He threads the paper under tubes in the acid, using rubber gloves to protect his hands and his arms. The tail broke and the other man catches the tail, puts it under the tube in the sour water and hands it forward to the washerman. That sour water is weak acid, but if it's left on his hands, it would start to burn. Note that he washes his hands before he goes ahead. The operator has to be careful that he does not get caught in these rolls. If a man gets caught, he can get pulled in and hurt severely. The tail broke again and is again handed forward to the washerman. The washerman is coming to the end of the sour water and is now being passed up and into the wash section. In the wash section, they have now entered the solution of soda ash, which completes the neutralization of the acid. When rolls or tubes get out of line, they can cause wrinkles in the paper. Therefore, sometimes they have to skip part of the rolls. We are now coming to the end of the wash section. Notice the clear, fresh water. They now go to the dryer section ahead of the size press. At the size press, a release treatment known as pull-on will be added. This paper will also be used as a bakery tray liner. This machine is threaded about 50 feet a minute. Once they have completed the threading, it'll be speeded up to over 300 feet a minute. This is a size press where the treatment is sprayed on and the excess is removed by the press roll. Now the paper goes over the final dryer section and to the reel. Notice how the paper gets wider once the tail has gone through the parchment machine. Once the paper is out to full width, it is put on the reel and wound up. We are still on number 41 parchment machine, and they are running the roll that you saw threaded through the machine. They're coming to the end of that roll and preparing to splice on the next roll. The operator brings the glued edge of the new roll of Waterleaf up against the old roll that is running. The new roll is now being led through the parchment machine by the old roll. The new roll of parchment has now reached the reel and will be started on a new core. In order to help the parchment bond to the new reel, the operator will pour a little water onto the parchment ahead of the reel. The old roll is finished and will be removed for further processing. The roll is on a steel core and is removed from the winder shaft. And taken away. A new steel core is loaded onto the reel shaft and prepared for the next roll of parchment. The dryerman now takes a sample of this finished roll of parchment to be sent to the test station to make sure it meets all specifications. A man from the roll storage area takes the finished roll for further processing. The dryerman is marking up the sample and will take it to the test station so required tests can be run. These could include wet and dry bursting strength, tensile, brightness, opacity, caliper, grease resistance, release from various compounds, and acidity of the paper, or other end-use tests for special customers. This is the roll room where rolls of parchment are stored until they are cut into shipping rolls or cut into sheets. This is the rewinder area. Here you see rewinders that will take the rolls from the parchment machine and cut them into shipping rolls specified by the customer. This is a finished roll being wound up at the rewinder. This is another view of the rewinder area. The printed and silicone treated parchment on this winder will be shipped to General Mills, who will use it to interleave their fruit products. We are now at a cutter which takes 10 large rolls, runs it through a rotary cutter, and delivers it to a skid. Here you see the cut sheets being delivered. These sheets are the proper size to fit a bakery tray. This is a special cutter, sometimes called a sheeter. It cuts greeting card parchment to the size required for printing presses at Hallmark or American Greeting. This is the finished sheets of greeting card parchment. We now take an overview of the parchment packing area where sheets of parchment are packed for shipment. Following are excerpts from a silent black and white movie made by KVP about 1929. This is a view from the top of the hill at Glendale Boulevard, looking over the city in the valley. The street you see is Glendale Boulevard. We are now coming to Mill 1. The small stack in the background with the smoke is Hercules plant that makes chemicals for the paper industry. The buildings in the front are the Mill 1 paper machine building. The big stack is no longer there, nor is the water tower. This is a house at the corner of Riverview Drive and Glendale Boulevard. The playground was where the Parchment Library now stands. This is the home of Mr. Kindleberger that is now used by an architectural firm. This is the school I attended in grades K to 10. It is now part of the Parchment Middle School. This was a community house that stood where the First America Bank now stands. It had a large auditorium used for company, school, and community meetings. The Methodist Church had its services there. It also contained a cafeteria and a gymnasium. It was maintained by KVP and heated by steam from the KVP power plant. You'll now see some views of Riverview Drive in about 1929. This is the office of Mr. Kindleberger. Each day he had samples of paper brought to him at his office, and he checked them for quality. The main office building was built in 1928. Mill number 2 was started in 1922 and was built and considered as the world's model paper mill. In keeping with the model paper mill theme, they put a globe over the entrance to the main office. We now start looking at paper making as done in 1929. At this time, rags were the source of cellulose fibers for parchment. This shows the sorting and cutting of the rags. Next, rags were run through a shredder. Now the rags are being fed into the cooker. We showed you the cookers as they are in 1996. This shows how they were used to cook the rags. This is a rag cooker that is now used to store wax. Note that they have to remove the cooked rags by hand. The cooked rags are put into a cart that is again pushed by hand. There were no fork trucks at this time. Now the men load the cooked rags into a pulp washer. This room is now the hydropulper room at Mill 1, and all these pulp washers and beaters have been removed and replaced by the hydropulper and refiners. This is the pulp after it is bleached. This is a rag pulp ready to be processed for the paper machine. This is a pulp beater where the rotary beater you see turning meshes against a stationary beater plate at the bottom and grinds the pulper to make them more flexible to make paper similar to the refiners. We now go to mill number 2. This movie had no pictures of paper machines or parchment machines at mill number 1. No pictures of the parchment machines in particular were allowed. KVP makes more paper with less water at the present time. This is a filter plant that was used to filter river water to be used on the paper machine. This plant has been torn down and they now use well water. This is a view of the Beloit paper machine that was started in 1928. The machine on the left is the Bagley paper machine that was started about 1922. This is the area where the paper is formed on the Beloit paper machine. This is dilute pulp for the Bagley machine being run over what was called a riffler. There was a screen on the bottom and fine dirt and contaminants were removed. This is a dilute stock flowing to the open head box of the Bagley paper machine. Now they use pressurized head boxes which extrude the dilute water so the machines can run much faster than if they were only using the pressure of the head of the water. This is the forming area on the Bagley paper machine where the water passes through the screen and the sheet of paper is formed on the screen. This is the water that has gone through the screen and is going to be recycled back to the head box of the paper machine. This is still a view from the wet end of the Bagley paper machine. After the paper is formed on a screen, it is transferred to a felt and run through presses to remove more water. Here you see the wet paper leaving the forming screen, going onto a felt and running through the press section. From the press section, the paper goes on to the steam-heated dryer drum. This is the paper in the dryer section, actually of the Bagley paper machine. When they have a break in the paper, the crew must come and rethread the paper machine. They have to start with a tail from the wet end, similar to what you saw on a parchment machine. The man is about to take the paper from the forming screen, thread it under the hooch roll and onto the felt. And up into the dryer section. This is paper leaving the press section.
On the dryers on the paper machine, they have rope carriers. They throw the tail into the rope, and then the ropes carry the paper through the paper machine. When they get to the dry end, the operators have to thread the paper through calendar rolls. At the calendar rolls, the man cuts a tail so that the other men can feed it onto the reel. When they have a break and paper collects, they have to force it down through a chute into the basement, where it is taken back to be recycled. Here we've reached the reel, and the paper will be wound up . We're still having problems at the calendar stack and the reel. They have just finished making one reel of paper and transferred the paper to the new reel on the left. Note that the reel they are removing from the paper machine is much smaller in diameter than what you saw on a current paper machine. They did not have equipment to handle such large rolls in 1929. This is paper being rewound and trimmed on the winder. The finished rolls were taken from the paper machine to roll storage, and this is the roll storage in 1929. Note how the individual rolls were handled, pulled by hand on the little cart. This is a cutter in 1929 that was cutting paper. This is a rotary knife that goes around to cut off the sheets of paper. This is the delivery end of the cutter, and sheets of paper are being piled. This man is operating a die press used to cut liners for barrels in 1929. This was parchment paper again. We're back at Mill 1. Waste parchment paper could not be repulped. They took it to a shredder and it was shredded into fine parchment that could be used like Excelsior or packing glass and other products. This is a shredder, and they made bales of parchment that was sold as Excelsior. This lady is counting paper. Each time she moves her finger, she counts 5 sheets. This man is in the Mill 2 bond room at KVP, cutting paper to be packaged in small packages. This bond room is no longer used and all the equipment has been removed. These girls are packing the paper that was cut at the trimmer.
You will note that there are many people working in the finishing area and in the other areas of the paper machine. At one time, KVP employed nearly 3,000 people. Now, there will be less than 500. In 1929, the paper left the mill mainly on railroad cars to be shipped all over the world. This is Mr. Kindleberger and Ralph Hayward, who succeeded him as president and chairman of the board. We are all sad to see part of their dream die.